This is Senior Algebra, Section 4.2, Solving Linear Systems by Substitution. So below, let's take a look at how we're going to solve these systems. In step 1, it says solve it one equation for either variable. Probably the most important step. I want to pick an efficient way to solve this. So when I do this, I'm going to either solve for x or y in one of the equations. I want to pick something where I don't have to divide too much, where I might get a fraction. I want to pick something usually where there's a coefficient of 1. So if I look at example 1, what's going to be the easiest variable to get alone? Well, the x is already alone. Great, pretty easy for us. So what I'm going to do is I'm going to substitute it in. Problem is, when I have that equation, 2x plus 5y equals 7, I can't solve. I have two variables here. So by substituting in negative 1 minus y for x, now I get one variable here. One variable, one equation, I can solve this here. When I do this, I'm going to take the 2, multiply it in. So I get negative 2 minus 2y plus 5y equals 7. Combine like terms, move stuff around. And I'm going to get y is going to equal to 3 here. At this point now I'm going to take that y and I'm going to substitute it back into one of the first two equations, one of the original equations. Doesn't matter which one, I'm going to pick the one on the right because it is easier. The x is already alone. So I have x equals negative 1 minus y. Key in this one is when we do our substitution, make sure you put stuff in parentheses here. This one it doesn't matter as much. Okay, but it will in the future, especially when we're multiplying. So I get x equals negative 4. At this point, my solution that I believe is correct is negative 4, 3. Well, I want to check just to make sure I am correct here. So how do I check to see if that is a solution? Well, if you remember when we did this last chapter, we have to plug it into both equations. So I'm going to take negative 4, 3, and I'm going to plug it into both equations. If it is a solution, I'm going to get two true statements. So I get negative 8 plus 15 equals 7, so I get 7 equals 7. That is true, so it works in that first equation. I'm going to do the same thing, plug it into the second equation. So I get negative 4 equals negative 4. That is true as well. Since it works in both equations, we say that negative 4, 3 is the solution. So taking a look at example 2, now we're actually going to have to move stuff around. We're going to have to manipulate one of the equations to get a variable alone. So if I want to choose, I want to look for something that's easy. So don't write this down, but watch what happens. Let's say I just want to get x alone. Okay, I could do that. Divide by 5, divide by 5. I get x equals negative 3/5 y plus 2. Now, that's not something that's going to be easy to plug into the other equation. Now, again, you could do it. It works. But with fractions, now all of a sudden I'm going to have to do a lot more extra work here. So we want to try to be efficient. If I look, the easiest variable to solve for in this one would be y. So I'm going to move the 4 over by subtracting 4 from each side. Don't forget about the negative with the y there. When I multiply by negative 1, I get negative 2x plus 4. At this point, I'm going to plug it into the other equation. So I'm going to substitute that variable into the other equation. That gives us one equation with one variable, which I can solve. So I get negative 1x plus 12 is 10, and negative 1x equals negative 2. dividing by -1, or multiplying by -1, and I get x is 2. At this point, I'm going to plug it back into one of the equations. Doesn't matter which one. I'm going to plug it into the second one. So I get 10 plus 3y equals 10, and I get 3y equals 0. Now again, we still have to solve it. So when I divide by 3, 0 divided by 3 is 0. So my solution, 2, 0. So looking at example 3, it's pretty easy to get the x alone in the second equation, but I'm going to do it a little bit differently. If I look, I have 2x plus 4y equals 6. I'm going to use the first equation. So I'm going to get x alone in the first equation. I have 2x equals 6 minus 4y. When I divide each side by 2, I get x equals 3 minus 2y. So we could do some dividing there. Again, it doesn't make that much of a difference. I looked ahead and I went, I'm not going to get any fractions. So I'm going to plug it in. I get -5y equals -2y. Distribute that negative. -3 plus 2y. And at this point now I look and I'm going to combine my like terms. So I combine the -2y and the positive 2y, but I get 0y. They cancel out. So I'm left with this, -3 equals -5. Well, is that true? No. What does that mean? When we had an untrue statement, when the variables dropped out, we had an untrue statement, it is no solution. If you recall graphically, what happened there? This would be the situation where we have two lines that never intersect, two parallel lines. There is not a point that would work in both of them. I don't know if the lines look like that, but those are parallel lines. Don't intersect, no solution there. So, the last one in example 4. Solve for either x or y in one of the equations. I would not solve for x here, simply because it would leave you with some fractions there. I'd probably solve for y in either equation. I'm going to pick the second one. So when I solve for y, I get y equals 3x minus 4.
Mrs. Schaefer, could you please call the office? Mrs. Schaefer, please call the office.
So I plugged in y into the first equation now. Distribute the -2. This is where your algebra has to be really solid. Even if you know how to do it, you can easily make some small mistakes here. So I get 8 equals 8. Is that true? Yes. What does that mean? Well, typically, the solution was all real numbers. Well, that's not really true. The solution is going to be infinitely many solutions. Now remember, what's the difference here? Well, if I think about what the graphs would look like, y equals 3x minus 4. I'll graph that one, the one on the right. That looks like this, up 3 over 1. And the other line is going to be directly on that line. They're the same line. So if I picked a point, -2, 5, well, is that a solution to it? No. There's only solutions that are on the line. So we say that there are infinitely many solutions because there's an infinite number of points on the line, but we will not say that there are all real numbers because every number will not work.